Okay, so this is now kind of applying what we talked about. And so we got this problem. And so we have a CH4, an NH3, and H2, and we got to figure out multiple things. We got to figure out the number of electron domains, the electron domain geometry. So when you see things like geometry, what they're asking for when you see the word geometry is they're asking for shape. So they're asking for shape, and so molecular geometry is also going to be shape. Bonded electrons, lone pairs, all the good stuff. But really, we're going to try and figure out that whole A, X, etc. So I'm going to put the A's and X's in here with the electron domain, and then we'll get it all sorted out. So let's start with the CH4, and let's go through the whole process. So first of all, the middle atom. Well, usually the first atom listed. So let's put that C in the middle. And now we're going to attach all the H's, right? And you just attach all the other elements to the middle, like this. And now we're going to go ahead and get our target number, right? Like how many electrons are we allowed to have? So we looked this up on the periodic table. So we've got to look up carbon and hydrogen, and we got to figure out how many valence electrons they have. Well, carbon's in column 4A. So carbon's going to contribute 4. And then the hydrogens are each going to contribute 1. But since there's 4 of them, you're going to add that up. And this structure gets to have 8 electrons. Okay, cool. So let's count. Well, back up. Let's add dots. The problem is we don't need to add any dots here because I can't add any dots to hydrogen. So if you start doing that, that's a problem. No dots to hydrogen, okay? Hydrogen's too little for dots. Does carbon get any dots? No, because think of this as a box. It has an attachment on each side. So 4 attachments, no dots. So this doesn't get any dots because the H's don't get dots, and I can't give any to the carbon. So now we're going to look, does our target number 8 match what we have here? So remember, everything counts as 2. 2, 4, 6, 8. So yes, it works. So that's my structure. So I can just go over here and jot in my structure. Okay, so number of electron domains. Okay, an electron domain is a bond or a lone pair, and it doesn't matter what kind of bond it is. It can be a double, a single, or a triple, and those are all one electron domain. So the easiest way to do electron domains is to just look at how many things are attached to the central atom. So the central atom has 1, 2, 3, 4 things attached. So those are 4 electron domains. So the number of electron domains are just the things stuck to the middle. And so these over here are all electron domains. So we got 1, 2, 3, and 4. Now, let's say, for example, that this was a double bond. It wouldn't matter. It's still 1 electron domain. So a double, a triple, or a single doesn't matter. So just count the things attached to the middle. Okay, the electron domain geometry. Let's do this with the A's and X's. So this would be an A, X, 4, E, 0. Okay, an AX4, E0. Number of lone pairs is going to be 0. There's no lone pairs because we just did E0, right? Number of bonded domains, those are the X's. So that's 4. And what would we call this? Well, AX4E0, we would go back, we would refer to our chart, and right here, There's AX4E0. So that's what this does. It gets me to tetrahedral. It gets me to the correct shape. So when I go back over here, that's the point of the A's, the X's, and the zeros, is to get you to tetrahedral. And the bond angle is 109.5. All right, let's try another one. Let's try the ammonia. So the ammonia is NH3. So let's put the N in the middle, right? Because it's listed first, and it's not an H. Can't have H in the middle. Remember that. So let's do this. All right. Dots. We got to add dots. Remember, you add dots, and I told you, think of it as having a box. Any side that is missing an attachment, like the top, you need to add a pair of dots. So we're going to go here, and I'm going to add a pair of dots right there. Remember, no dots for the H, right? Because the H is too little. Can't have dots because it can't have any dots because it's fine with just being attached. So we leave the H's alone. So there we go. Let's figure out the target number. Okay. We look up nitrogen on the periodic table. It's going to be in column 5A. That means it has a valence number of 5. So it can give 5 electrons. The hydrogens, of which we have 3. So 1 times 3. Add all that up. 8 electrons. So this has also, like the one above it, can have 8 electrons. Let's count. 1, sorry, everything counts as 2. 2, 4, 6, 8. Oh, it works. There we go. Super easy. They don't have to be hard. So let's go ahead and write it in. All right. How many electron domains? Okay, remember, anything attached to the middle is an electron domain. And so just like we did previously, this is going to be 1, 2, 3, 4. So an electron domain is just an attachment to that central atom. Now, a lone pair is just one domain, right? A single bond is one domain. A double bond is one domain. A triple is one domain. So this has 4, same as the one next to it. But here's the difference. It's not the same shape. It's an AX3E1. So when we go and look that up, AX3E1 is pyramidal shape. So 1 lone pair, 3 attached atoms, and then this is pyramidal. And then a 107-degree bond angle. So you can see they both had 4 electron domains, right? So they both had 4 things attached to the middle, but they actually created a different shape. So if we look at the last one, which is water, I'm going to have to, I'll kind of squeeze it in right here. Squeeze the water in here at the bottom. There we go. So the water, so first of all, you can't put H in the middle. So it's going to have to be the O. So it's going to look like this, H to O to H. Now we got to put in the dots. You don't get any dots on H, but O has nothing on the top. and nothing on the bottom. So if you think about a box, it has something on the left, something on the right. You need to add dots to the top and the bottom to get it nice and stable. So now we look at our target number. O is in column 6A, so it gives 6. Once again, that should be on your periodic table. You should look it up. I'm not going back and forth to show you the columns, but it's the column of your periodic table. Hydrogen's in column 1. Hydrogen's in column 1. So it's going to give 1, but there's 2 of them. And when we add this together, we are, of course, going to, again, get 8. And if we look, remember everything counts as 2. So 2, 4, 6, 8. Yes, it works. So we'll go ahead and put it up here. Like so. How many electron domains? Again, everything attached to the middle is an electron domain. So there's 1, 2, 3, and 4. And so you can see every one of these has 4 electron domains. But again, this is going to be a different shape. It's an A for the central atom, X for the 2 H's, the 2 things that are attached, and then E2. So there's my A, there's my 2 X's, and there's my 2 E's. So that's how we're doing it. So the A is the central atom, X is anything attached to it, any elements attached to it, and then the E's are the lone pairs. But an E is 2 dots make 1 E. So be careful about that. Like that would be 1 E, and that would be the second E. Okay, number of lone pairs, 2. Got them up here. There's 1, there's 2. Number of bonded domains, so that's the X's. So like I can even right here, that's an X, and then this is an E. So AX2E2, well, we go back to our notes. And we're going to have to go back to the very first page. AX2E2, right there, bent. So that's a bent molecule. So we go forward, and it's bent. And once again, they all have a slightly different bond angle because their lone pairs are going to be a little bit different than the lone pairs will be a little bit different than the bonded atoms. So this bond angle, I know I put 120 in the notes, I think, to make it easy. I guess we'll go with that. That's a little bit of a generalization. So anyway, it gives you an example, trying to figure out what they are based upon the A's, the X's, and the E's. So if we go here, example 4, I want you to go ahead and pause the video. I'll work through all these with you, but I want you to figure out what these are. So when this says molecular geometry, it is asking for the shape. So you need to find the A's, the X's, and the E's, and then tell me what shape would that be. All right, so that's what we're looking